All right, Algebra 2, we are going to start graphing more today, graphing with asymptotes. So an asymptote is it's kind of like a yellow tape line at a crime scene. You're not allowed to cross it. Your graph is not allowed to cross it. So here our equation is y equals 10 over x minus 5. And we are going to walk through exactly every single step that we need to do to graph it. So our first step is to find the y-intercept, and to do so, we're going to plug in 0 for x in the equation. So we're going to take this 0 and we're going to put it right in for the x right here. So 10 over 0 minus 5 simplifies to 10 over negative 5, which is obviously negative 2. And if we wrote it as a coordinate point, that would be 0, negative 2. Next thing, we're going to find the vertical asymptote. So that is the line that we're not allowed to cross that goes straight up and down over here. It would look like this. And we are going to set the denominator, so that's the bottom of the fraction, equal to 0. So the bottom of our fraction is x minus 5. We're going to set that equal to 0, solve for x. We're going to move that 5 over, so the opposite of a negative 5 is a plus 5. And x equals 5. So if we took a 5 and we plugged it into the denominator would be 0. And we're not allowed to have the bottom of a fraction be a 0 in math. That's why this is an asymptote. Next thing, we are going to find the horizontal asymptote. So set the numerator to 0 if possible, but obviously there's no variable up here to plug into. So the numerator is stuck at 10, right? Couple tricks for the trade here. If the degree of the numerator is less than the degree of the denominator, which is the case we have here, right? So it's really kind of like 10 with x to the 0 power. So our degree up here is 0 since there's no variable, and the degree down here is 1 even though you don't see it. So 0 is less than 1, so our degree of the numerator is less than the degree of the denominator. So first things first, there is no horizontal asymptote. And second, we would call this a proper function because the numerator has a larger degree than the denominator. Second kind of trick of the trade, we have if the degree of the numerator happened to be or if the degree of the denominator happened to be less than the degree of the numerator, then the horizontal asymptote would occur when the top of the fraction was set to 0. And then it would also be called an improper fraction. So we just have the first case here, and now we're going to graph it. So we have a vertical asymptote, but not a horizontal asymptote, and we're going to graph it. So we have this vertical asymptote, and we're going to find some points. So as we approach that vertical asymptote from the right, so that means kind of going this way. So we're starting on the right side of the vertical asymptote, and we're going towards it on the graph. So we're going to choose x values that get increasingly closer to 5. So I just chose 6, 5.5, and 5.1 just for some points to plot. And as we can see, if we plug in 6, we go up to 10. Say that's right about here. I know that's not accurate, but I'm not a perfect artist. If we get a little closer at 5.5, we see we go up to 20. And then if we get even closer at 5.1, we go all the way up to 100. So our graph is just going to keep going up and up and up as we approach this asymptote. Whereas from the left side, at 4, we are down here at negative 10. At 4.5, so we're getting a little bit closer, we're down here at negative 20. And at 4.9, almost to the asymptote, we're all the way down here at negative 100. So as we approach from the left, we're going down, 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 down. And if that doesn't make sense to you, there's a little easier way on the next example. And we'll just move on to the next example. So our next equation is y equals 7x plus 5 over 2x plus 6. Again, same kind of steps here. Let's find the y-intercept. Let's plug in 0 for x. So if we plugged in 0 for x in our equation, it's 7 times 0 plus 5 and 2 times 0 plus 6. Well, these cancel, so what's left over? Just 5 over 6. If it works for you a little faster, if you notice that the degrees of both these exponents are the same, just use the constants at the end. The vertical asymptote, we're going to set that denominator to 0. So 2x plus 6 equals 0. And we're solving for x, and we see that x equals -3 in this case. So we do have a vertical asymptote. We need to find the horizontal asymptote. And here, they both have the same degree. Both the denominator and the numerator have the same degree of 1. So when this is the case, we just use their coefficients. And our coefficients are 7/2. So our horizontal asymptote is y equals 7/2. Now we need to find some points. So you could do it this way. You could pick points getting closer and closer to our vertical asymptote of -3. So like -2, -2.5, -2.9, getting closer and closer from the right. And you could choose points getting closer and closer from the left, like we do over here. Or I would plot the vertical asymptote and the horizontal asymptote first, and then just plot your y-intercept. So our y-intercept was at 0 and then 5/6. And since it's in this quadrant, so there's kind of 4 quadrants right here made by our 2 asymptotes. Since it's in this quadrant, we know that it's just going to go towards the asymptote. So we know our line is going to go right here towards the asymptotes, and then it's just reflected on the other side. Hopefully that makes sense. If not, you can always just count on kind of the old reliable plug-in chug. If you have questions, shoot me an email.